Hello. Y'all can hear me? Excellent. Okay. It was so weird what happened last week. Sparta, Silvera, Dan. There's probably like several Dans here. Leonard, Tortilla, hello. Ruby, Emmy Rose, Super Terrific, Fixter, Jake, Nikki. Yep, another Dan. Jada Tempest, Redshaw, hello, hello. How are we all doing this morning? Oh, sorry, casual. Didn't mean to startle you. Wookiees, Cricket, Ams. How are y'all doing this week? Sorry I was a little late in getting started there. I was having a meeting. I have to go do some field work tonight after we're done here. So I was on a meeting making sure I had everything ready to go for that. But, oh, nice quick find. Nice good little wolf spider here. Oh, Wookiees, you saw a longhorn beetle last night? That's awesome. Ams, I can take pictures for sure. So I got roped into / I volunteered for, that maybe I shouldn't have, a scorpion project recently. A friend of a friend, Cat Alexis, yes, hello. A friend of a friend was like, hey, we need somebody in Phoenix to go out and look for this specific species of scorpion. And so, yes, Agent Zan, it is indeed a little bit late. So I have to wait for 2 hours after sunset, and then I have to go scout random alleyways for their bark scorpion populations. Hello, Miss Riley. Yes, that's exactly what I'm going to be looking for. So, it's an IPM grant, or an integrated pest management grant. And so what we're going to be looking at is seeing whether or not scorpions are actually more active during the new moon when it's super totally dark versus the full moon when it's, in theory, naturally as bright as it should be. And then that will get extrapolated into, like, pest management spheres of things. I'm not on that end. I'm just on the scorpion hunt. So I'm going to take a blacklight flashlight and go scout some sites, some really fun parking lots and alleyways. Yeah, here, another friend that we're used to seeing. Sorry, excuse me. Our dung beetles are back. This looks different, though. This is... Oh, I want this one to come out. This might be a different species. Ooh. Yeah, this is different, y'all. So this... Ams, it's never too late. So this is a... How am I going to go explain this? This is a type of beetle that does indeed feed on... There's another. These are types of beetles that do feed on dung. However, they're not quote-unquote dung beetles. These are called earth-boring scarabs or earth-boring dung beetles. These are actually the family Geotruppidae rather than Scarabaeidae, which is what the normal dung beetles are like. Now, how do I know that? The vibes. the vibes are right. The vibes are right for it. If you had a microscope, you would be able to tell that geotruppids have one more antennal segment than scarabs do. But these are also a little bit more elongate. And they have that little triangle behind the pronotum. So the pronotum is that neck shield piece of an insect. In beetles, it's pretty wide, and then you have the elytra, or like the wing part. There's a little tiny triangle there that basically separates where the wings attach at the very top. And in dung beetles, the true dung beetles, the scarabeines, and the ones we're used to seeing, they don't have that triangle visible. In geotruppids, it is visible. So they do very similar things. Tortilla, let me click on that. Yeah, it is one of those. Lots of species, and there are quite a few of them in Texas, so I'm not sure exactly who these are. But yeah, so they do very similar things to the dung beetles, and we've even talked about these before, actually. Do you remember when I was talking about the Florida deep digging scarab, the one that can have the like 3-meter long tunnels? That was actually a type of geotruppids geotruppid as well. Lots of spooters tonight. Little Miss Riley, yes, they are indeed. June bugs are a type of beetle, and they are also a type of scarab beetle. So, pretty closely related to what we're talking about now. Alright, who's this? We know this one. Logan, you're doing amazing. If it stops for a second, we might be able to look at some things that tell us. Of course, it stops right behind the hay. That's not where we needed you to stop. But that was incredibly impressive tracking, actually. So, big shout out to Logan. Oh, spoke too soon. So this one isn't a wolf, guys. This is another spider that we have talked about before. He's, yeah, really busy. Zooming and scooting along here. And we lost it. That's okay. So that was another ground spider. We've talked about them before. The Gnaphosidae family. I'll go back and see if I can look at the clip and send post a screenshot of it in the bug cord after we're done. But he had those really short and stout, kind of quote-unquote barrel-shaped spinnerets, so the parts that the little prongs on the end of the spider butt that actually lay the silk down. In wolf spiders, they're pretty elongate, and you usually don't see them because they're tucked up against the abdomen. But in Gnaphosids, oh, hello, Acero. In Gnaphosids, those little spinnerets are much shorter, and they're like smaller and blunt. So they're not going to be long, they're not going to be fingery. You can kind of just look like little knobs on the back of the abdomen there. Agent Zan, exclamation point bug cord. That'll get you there. Or Nikki, yes, thank you. Speaking of spiders, daddy longlegs is a type of arachnid, but not a spider. It's a harvestman. Yes and no. So, ooh, who's this? We got a piece of a fly? A whole that's a whole fly. But yeah, so Little Miss Riley, we do see the harvestman on screen quite a bit. There are some pretty famous clips in the Alveus lore about those guys. But daddy longlegs, depending who you talk to, can refer to like 3 different groups of organisms. You have, like you said, the harvestman, which is its own arachnid group. But you will also see people calling cellar spiders, the family Pholcidae. You will see people calling those daddy longlegs too, because they do also have very, very long legs. And then, if you're British, the crane flies. So we've seen crane flies on stream here before, but in Europe, apparently, I've never actually heard anybody say this, but everything that I've read says that the Europeans will call crane flies daddy longlegs. And so, it's important to make the distinction which one you're talking about there. Because if you start telling the British folks that the daddy longlegs are, if a British person starts telling an American that the daddy longlegs are flying, we're going to have a big news story because we think arachnids have grown wings. Definitely thought crane flies were basically daddy longlegs with wings. Hey, I mean, they're similar. And femto, yeah, that's another one. Skeeter eaters, they don't actually eat mosquitoes. So, common names again betraying us. They do look like mosquitoes, and they are closely related to mosquitoes. I talked about this, it's been a while now, but back when we talked about the Jurassic Park thing, crane flies and mosquitoes are very closely related, and they share that similar body plan because they share an evolutionary history of being like long and leggy. But what was I going with that? Oh yeah, adult crane flies either have vestigial mouthparts, meaning they don't eat at all as adults, or they feed on like pollen. As far as I know, there are no predatory crane flies in the adult stage. There is a few examples of crane flies that have predatory larvae. That the larva is also aquatic, so it will in fact eat mosquito larvae. So it sort of works out, but not always. Brewery, we can confirm called crane flies daddy longlegs here in England. Thank you. Thank you for the British input. Super terrific. What is the deal with whirligig beetles? Why do they swim like madmen? And why do I keep finding them on the roof of my car? Can I ask a personal question, Terry? What color is your car? So whirligig beetles we have also talked about before. That is the family Gyrinidae. Oh, red. Whoa. Man, that ruins my follow-up. Whirligig beetles are the ones you find them swimming kind of in masses on slow moving water. And they're really, really cool because they actually have a divided pair of eyes. So they only have 2 eyes, but they have a pair that's situated on top of the midline of the body to see above the water while they're swimming. And then it's basically divided so they can also see underwater at the same time. So it's not 4 separate sets of eyes. There's just one eyeball, but there's a canthus in the middle, or like a shelf in the middle, that when you put that beetle in water, it sits perfectly level with the portion of the body, like half underwater, half above water. So very, very cool. That being said, obviously they are aquatic, and the reason I asked about the color of your car, and the reason why red doesn't really fit into my scheme here, is that oftentimes at night, the paint on like blue and green and gray cars apparently looks like water to a lot of insects. And so you'll oftentimes find aquatic insects on your car in the morning, or if you go out at night, because they've landed on your vehicle and think it's water. But that doesn't really go with the narrative here if you have a red car. It might just be the season for them. They obviously can and do fly, so they have to get from one space of water to another. But finding like multiples on your car is quite interesting. What do you mean everybody's saying don't get a car in those colors? That's the reason to get these cars. So when I did my undergrad back in Florida, we had general entomology classes to collect for, and one of the things that people would want were water scorpions. I know Maya's posted about them a few times, but they are very long and slender. They sort of look like an aquatic praying mantis, but they have this long tube coming out of their butt. And it's not a stinger, but rather it's a snorkel. So they have this really long tube and they float head down underwater, and they'll just have the little tip of this siphon or this snorkel up out of the water so that they can bring oxygen down to their spiracles. But for whatever reason, when I was taking that class, everybody was having a hard time finding them. Except one night, I was working late, and right across the street from the entomology department, there was a little pond. And when I went out to my car, there were 6 water scorpions sitting on my dashboard. Or sitting on the hood of my car. No dark, no sewn. It's not an egg-laying tube. It would look very, very similar, but it is not the same sort of function. But yeah, so after nobody was able to find them all semester, I found 6 in a night, and they were all sitting on the hood of my car. If this guy pokes out, we do have a big beetle situation going on here. Okay, this is a tenebrionid. I was hoping this was one of our first big ground beetles of the season, but this is a darkling beetle instead. So, this is the same family with mealworms in it. Am's water scorpions, the family name is Nepidae, Nepidae. Internet Loma Linda. Oh, that's pretty cool. This is a big beetle situation. So these are darkling with an L, darkling beetles. And these are super common. We will probably see lots of these in the upcoming months during chat chats. Texas has a ton of different species. Thank you, Ophelia. I'm glad you made it tonight. So this is the same family that has mealworms in it. So if you've ever bought or seen mealworms for like fishing bait, or most of the time reptile food. Ooh, Stompy Feather going crazy. If you leave those beetles, or you take care and feed those mealworms long enough, they will eventually turn into a full-grown beetle. And a lot of the time, people will post on some of the reptile keeping pages, like, "Oh my God, what's this alien thing that I found in my lizard tank?" And it's like, well, it just didn't eat that worm, and it turned into a little pupa. So it looks pretty funky, because that's the intermediate stage between the larva and the full-grown beetle. But yeah, there are a lot of different ones. These are the ones that can stink. I saw Roxers asked about that. Out here in Arizona, at least, we have a lot of different ones that will stick their butt up in the air, kind of do a handstand, and they do have a very, very potent chemical defense. They don't shoot it out like the bombardier beetles do, but it is a very stinky situation. Can we get some more zoom and enhance on this guy? I'm seeing some eye shine, and I don't think that crab spiders have eye shine. I think this is another wolf. We're just getting a funky angle on it because we're looking at it sideways. You can see the abdomen on the left closer to the fence. Yeah, I think this is just another wolf spider, but we are actually seeing the ants coming around here too. These might be the fire ants, so we don't like these as much, but casual, it's okay. It's hard. It's tricky. Crab spiders, though, do tend to be wider. Their abdomens aren't quite as long. They're usually squatter, and definitely the front half of the body is wider than the back, giving them that sort of like horizontally expanded look, which is where they sometimes get where they get the name crab spiders. Riley, yes, the Tapetum lucidum. Who's this one? Who do we got here? Uh-oh, chat. Uh-oh. It's Weevil Wednesday. Not just a beetle. This is a weevil. So it has that nose sticking out of the front there, and also has the elbowed or the geniculate antennae. Boots and snoots, yeah. I don't know if I've told you all about this yet, but in late July, there is a beetle identification course that I'm going to be teaching down at a research station in southern Arizona. And then immediately following that, there is a weevil identification workshop that I will be taking as a student. So I will be down at this research station for about 3 weeks straight, which is super exciting. Hanging out in southeastern Arizona forever is basically the goal of what I want to do. But yeah, it's been a while since I've taken one of these identification classes, and this is the first time they're offering the Weevil workshop since 2017, I think. So it's been almost 10 years. They finally have the instructor team ready for it. They've had some restructuring going on, but yeah, I'm gonna have 9 days straight of Weevil identification workshop, and so hopefully I'll have a lot to report to you all during that or after that, and if we start getting weevils on the pollinator cams, I'll be able to tell you a little bit more about this. I know this one, at least to start, is the subfamily Entomini, and they're the broad-nosed weevils, or short-snouted weevils. I know when people think weevil, they oftentimes think of the, like, super elongate rostrum that we have seen before, and I know I've linked before, definitely. But, Entomines, these short-snouted or the broad-nosed weevils, as the name suggests, their nose isn't quite as long, but it is shorter and broader. But yeah, everyone is pretty active tonight. Definitely, even in the background, you can see some little guys moving around. And I anticipate we're going to have a good summer. Alveus got a lot of water recently, and then it heated up. So those are like 2 perfect recipes for getting bugs to be more active. So we are seeing lots of activity and even lots of new stuff happening tonight, which is pretty fun. Official species named little guys. They are indeed little guys. They can get pretty big in the tropics, though. Everything does tend to get bigger in the tropics. Dazettes, 9,000 species. It's more than that. So weevils are, depending who you talk to, the most or the second most speciose family of insect in the world. So there are over 60,000 described species of weevil, and there are also over 60,000 described species of rove beetle or staphylinids. And so I don't know how many of those weevils are entomines or the broad-nosed weevils. It's a pretty big group, so I would guess that there's more than 9,000 broad-nosed weevils. But I truthfully don't know. If you can hang on to that question until the end of July, I'm sure I will have that answered at Weevil Course. Weevils notable for their size differences, because I know green weevils are super tiny. Do other superfamilies have much variance? Yeah. I will grab some super tiny and super big weevils from the collection here and post them in the Discord, but weevils do have a pretty large size variation. Scarabs are another group that have a lot. The ground beetles have a lot, because some of the ground beetles are like less than a millimeter long, but then you have the violin beetles and stuff like that, stuff on that size, which are like 4 or 5 inches long. So there's a lot of variance in a lot of bugs, but there are some that are known for being tiny. Like Teleoids, the featherwing beetles. Maya's talked about these on stream, and I know she's also talked about them with Hassan before. But these are the smallest non-parasitic insect that we have, and they are like 0.01 millimeters long. No, that's too small. Smallest beetle. Hold on, we're fact checking live. Smallest known beetle, non-parasitic insect, 0.32 millimeters long. So, very, very tiny, and as far as I know, there aren't any Teleoids or featherwing beetles that are over a millimeter long. So that entire family is so small. Luna. That's polar gigantism, but only applies to some groups. Yeah, so insects in colder regions do tend to be smaller. I'm thinking about this as I'm saying it just to make sure that that's true. And yeah, I mean, insects do operate differently than mammals do, and in order to be able to produce enough body heat to sustain an endothermic lifestyle, you do have to be bigger. But you get some pretty decently sized ground beetles at the extreme, so I don't know. It's hard to tell, but in the tropics, there's a lot more availability of food, and they don't have to worry about their thermal tolerances as much. So in the tropics, that's where you start getting your the Hercules beetles that are like 6.5 inches long. You start getting the Titan longhorns that are the largest beetle in the world. So a lot of it has to do with climate, and I think not having to deal with cold at all, ever, year-round. So yeah, bugs do tend to get bigger and more diverse in the tropics. Dazettes, I'm glad this is goated. Bulking to sustain my endothermic lifestyle. Yeah, stay hard, Wookiees. There were millions of years ago when bugs were giant. Yeah, I don't know if I would have liked that time. Meganura is like the big famous example that you're probably talking about, Courtney. That's like the dragonfly with the 3-foot wingspan. But as Maya has talked about, and I think I've mentioned it on here before, like, dragonflies have something like a 90% efficacy rate when they go hunting. And so imagine something with a 90% accuracy taking down its prey, but make it 3 feet wide. I feel like that would be scary for us. Would love to see it, obviously. It's very, very cool. But I think the implications there of where humans would fall in that relationship, I think we'd be in a little bit of trouble. Yeah, Dazets, glad you're here. I don't know that I've seen you at bug hunts before, so if this is your first one, welcome. We do these every Wednesday, same time, same place. And yeah, ecosystem services is definitely one of the like primary ways that I try to get people to care about insects. Everyone knows about pollination. That's obviously a very big deal. But as we're seeing in real time right now, the dung beetles, getting rid of dung, if there weren't dung beetles, we would be up to our ears in poop of various sorts. This guy is looking like he's having a bad evening. He might be getting got by the ants. It's really interesting. So that's a fly. Yeah, that head's weird for Hymenoptera. That might be a Pyophilid. That's like really testing my ID skills at that point. But Pyophilids, they're called cheese flies sometimes. They've got, I guess, skipper flies. They have that same sort of shape, and their larvae are known to jump a lot, which is where they get the name skipper flies. But there is one called the cheese skipper, which is the Pyophila casei, and that one is a pest that was a problem more back in the day when we didn't really have food safety storage things, but it would breed in like cheese and dried meats. 100 men versus 1 Megan. That's funny. Cherry season, all the bees are out. How big were the prehistoric giant dragonfly babies? Did they start tiny like modern ones, or were they giant nymphs as well? That's a really good question, Terry. I don't know. Off the top of my head, I don't know. What's the note for that I need to write for myself? Ancient dragonfly nymphs. We're switching scenes. I would imagine they, in fact, would be bigger. Dragonfly naiads, or the nymphs as they are, the babies are also remarkably successful predators even to this day. They have they have this really cool thing called a labial mask. So if you remember, we've talked about the labium before with insects, but dragonfly nymphs have this like mechanical arm basically under their chin that goes out and scoops and grabs food back to their mouth. And we also have talked about how insects have influenced movies before. And Alien, the xenomorphs, the life cycle was based on parasitic wasps, but the thing that the alien does where it has like the little mouth inside of the big mouth, that was directly taken, or the inspiration for that directly was we're no look. Y'all, we're interrupting. That inspiration for the mouth within a mouth thing directly came from dragonfly nymphs. But Terry, I don't know if we have much fossil evidence of the nymphs, but I will definitely look into that, because now I'm curious as well. Beetles were originally pollinating the pollinators from magnolias. Yes, that is very true. Magnolias evolved before most of the other pollinating insects evolved, so like your typical bees, flies, and butterflies. So they are still, to this day, pollinated by scarab beetles. And there's always this question of which came first and like which caused the diversity explosion, but like insects diversified with flowering plants, and flowering plants also diversified as a result of having different insects around to pollinate them. Sexual dimorphism, Roxers put a pin in that. I will come back to it in just a second. Just catching up right now, because I'm quite behind, I fear. Okay, no look, no look, no look, no look. The frogs are wrestling. Your goth GF, you saw a spider and you didn't panic or squish. Love that. Kissing Wookiees, that they are indeed. Okay. Roxers. Sexual dimorphism. Dung beetles are, and most scarabs, to be quite frank, are like the typical examples that you see in beetles that have like extremely noticeable sexual dimorphisms. It's just like with deer, the males are the ones with the ornamentation, and they use those to compete in various ways for access to females or for access to resources that make them more attractive to females. And so you see that with scarab beetles. In longhorn beetles, the cerambicids, I don't know that we've had one on stream, but we've definitely talked about them for various things before. In that way, male longhorn beetles will have longer antennae than the females do. And that is a pretty standard sexual difference between male and female insects, is differences between the antennae. We see it in moths, we see it in scarab beetles, we see it with these longhorns. The reason that males generally have the bigger, fluffier, more sensing antennae is because they need those. Oh, little tadpole swimming around. He's cute. The reason that the males have the more extreme antennae is because the antennae are the nose of the insect. They don't have a nose, so to speak, but they do still have ways to chemically sense and take in smells from their surroundings. And the more surface area you have on your antenna, the more chemoreceptors, or like scent spots, you have on there. And because a lot of insects will use pheromones to attract males, the females will put off the pheromones, and then the males, with their big fluffy antennae, or in longhorn beetles' cases, their very, very long, exaggerated antennae, they're able to pick up those female pheromones from further away and hone in better to be able to find a mate. I I don't know if I've talked about this yet. I think I posted a picture of it before, but really haven't talked about it on chats. Sometimes sexual dimorphism in insects can get split, and you can have what is called a gynandromorph, which is where the insect is half male and half female, usually like split right down the middle. And this probably happens more often than we think, but it's really rare to observe, and it's hard to find in species that don't have very dramatic sexual dimorphisms. But there are examples out there where males and females will look totally different, and like with butterflies, you would have two different wing patterns split right down the middle. And so when I was in Thailand last summer, like right before I started doing Alveus stuff, I found a bilaterally gynandromorph moth in Thailand. And so side by side, on the same organism, you can see what the male antenna versus the female antenna looks like. And I will definitely post that again, because it is, in fact, one of the coolest bugs that I've ever found in my entire life. Sorry, catching up again. Like a Wi-Fi router. Yeah, kind of. Same idea. But yeah, so it can be bilateral, where it's split specifically straight down the middle, or with butterflies at least, you can have what are called mosaic gynandromorphs. So it's like front left wing and back right wing are male, and then front right wing, back left wing are female. It can get split like that in different pieces, and like I said, it's hard unless it is a species that is notably different. It probably does happen more than we would think, but there's not as many people out looking for them, and it's evolutionarily not the best strategy for survival, so there probably are some limitations and genetic factors that would expose them to more predatory risk and things like that. Wikipedia has gynandromorph katydid. That's very cool. Are there bugs with social structures outside of like ants, bees, and wasps? Yes. Termites are definitely one. Kissing Wookiees, that's very sick. That is in fact a longhorn beetle. That is in the genus Prianus, and that's a male. So if you look on if you would have seen the other side, like the underside of the antenna, the segments would be a lot more visible. You're seeing the top right now, and these ones in particular have like expanded segments. So it doesn't look quite as specifically divided up, but yeah, that is a longhorn beetle, and it's the genus Prianus, Prionus. Going back to your question, Limnoluna. Termites are another big one that has true sociality. So like the same sort of division of labor and reproductive brood care and stuff that you see in ants, bees, and wasps. But it has evolved in other places. As we've talked about several times before, termites are just really specialized cockroaches. And for a long time, we thought that, but we didn't really have evidence for it. But there is a genus of cockroach called Cryptocercus, which looks pretty similar to the Barbaras and the baked beans, big wingless, subterranean-ish cockroach that lives in the southeastern United States, that lives communally, which is one of the aspects of sociality, and also eats wood. So that was like basically the missing link between cockroaches and termites. And you see that subsociality and like hanging out in groups, more or less, in a couple of different places across insects. You have best beetles, the family Passalidae. They are a scarab relative that also lives in wood, but living in wood is not one of the precursors for sociality. Just happens to have worked out that way. And they will take care of their larvae. And the larvae can actually make like 17 to 22 different squeaks so that the adults know what's going on. They communicate with the adults, and the adults can communicate with the larvae. So that is one layer of sociality. You will also see some parental investment after the organism has been born, and that is like the very basic type of sociality, because that is like you are providing for your genetics, so that is like the most foundational thing in evolutionary biology. But there are some tortoise beetles that will lay the eggs and then stand guard like over top of the larvae after they've hatched. And you will also see this sometimes with like plant hoppers, that after the nymphs hatch, the mother or the parents will stay by them and kind of do what they can to ward off predators. And so that is like the basis of sociality. Is generally the first step is going to be parental investment. But the best beetles do take care of their larvae after they've hatched, and then they continue to live in these like familial groups inside of the log, which is very cool. Pixel logic, yes, definitely. Way back, but everything came from something at one point. So yeah, there is a point where we split off from insects, and we do have a most recent common ancestor with insects. That most recent common ancestor, recent should probably be in quotes, because it was many millions of years ago. But yes, we did at one point. Yeah, Luca. Bug cousins. You know what? Hell yeah. Hell yeah, bug cousins. We've been doing good tonight, y'all. It's we've only got about 10 minutes left. Time's flown. We've been having fun, I guess. Anyone have any burning bug questions for me that they've wanted throughout the week? We found a lot of cool stuff tonight, so I haven't really been getting backlog questions, but if you have any. These, oh, no look. No look. Tortilla. What bugs are good at living in burning environments? Yes, there are a lot of answers for that. Dezets, we'll get some moth facts in here for you too. There are insects that are they're pyrophilic, which means that they have an affinity for, they're like attracted to fires. Certain ground beetles, so the group that I work on, are very highly reported in burned areas, but we don't really know why they're showing up yet. Because ground beetles are predatory, they're not really going to be going after the burned stuff as much. But certain species of buprestids, or the jewel beetles, are pyrophilic because they lay their eggs in burned wood, and so the larvae then feed on the remnants of the burned wood. And those... Oh, he's stanced up. Those jewel beetles have basically heat-seeking abilities. They have special organs that allow them to sense heat and sense when fires happen. And so beetle collectors will go to areas that have just burned with forest fires and do a lot of collecting, because there's a lot of stuff that will show up to that. Even last week, I know we talked about the Megarisa wasp, the one that has the like really, really absurdly long ovipositor, and they will often also times go to burned areas because the wood is just a little bit softer, so they're able to go and reach those other insect larvae in the wood easier after it's been burned. Let's see. Moth facts. Moth facts to round this out. I know there's so many moth facts. Let me keep thinking on that, see what else is going on here. Riley, is there an arachnid that a southwestern grasshopper mouse cannot eat? I don't think so. Grasshopper mice are pretty vicious, which is cool. They also howl. But they're known for taking out scorpions, and I've personally seen them eating Arizona bark scorpions, which are the most venomous scorpion that we have in the US. So I'd imagine they'd be fine with most other arachnids, because if they can eat the most venomous scorpion, they wouldn't have any issues with the other species. And I don't know that they're like going after tarantulas actively, but like I bet they could. Nicole, you're here. Hello. Oh, the lid's off. Chat, he's in there. I can see his little hands. Murray hens. Why are there so many species of beetle? That's a great question. There's a couple of hypothetical answers that these are reasons why we think there are so many beetles. I don't know the answer 100% for sure. So we talked about one already, is that insects and plants co-evolved, and a lot of things that feed on plants specifically, so like weevils, the reason there's so many weevils is because a lot of them specialize. So there are weevils that are on pine. There are weevils that are on milkweed. There are weevils that are on XYZ plant, you name it. It has a weevil that kind of goes along with it. Another reason that is usually given for insect diversity overall, and like why certain groups like beetles and butterflies and flies and wasps all have such high species numbers compared to other ones, is this idea of the differentiated life cycle. So with crickets, with praying mantises and things like that, the adults and the larvae the adults and the nymphs look very similar, and because of that, they feed on very similar things. And so when times get hard, you have parents and offspring competing for food resources, and that's not good evolutionary genetics. Because if you're competing with your offspring for food, you have to make a choice at some point. But the big four orders, so Hymenoptera, the ants, bees, and wasps, Lepidoptera, the butterflies and moths, the Coleoptera, the beetles, and the Diptera, the flies, those are the four most diverse insect orders on the planet, and they also happen to be holometabolous insects, meaning they have that four-stage of egg, larva, pupa, adult, so your standard butterfly life cycle. But what that gives you is an evolutionary advantage, because your offspring, your caterpillar, is not competing with you, the adult butterfly, for food. You are still able to reproduce, and as an adult, still get the food and not compete with your offspring. And so that is a strategy and a reason why those four groups are so successful. That's another reason why there are so many beetles. And then Lastly, the elytra. So the wing covers, the hardened wing covers on the backs of beetles, they help them be able to live in spaces where other insects can't. Imagine you're a butterfly and you're trying to live in this nice pile of Winnie Pooh that we're looking at right now. You can't, because your wings would get all covered with poop. And the same thing for living in like really thorny plants or underground even. They can't do that because their wings would get messed up. And beetles have these really hard shells on the outside, these elytra that cover and protect the flight wings. And that is such an important defining beetle character that that's what the order was named after. So Coleoptera, coleo, comes from the Latin for sheath, like the sheath of a sword, and ptera means wing. So the order name for beetles is wing sheath, because that's like such a big defining thing of beetles. And because they've been able to get into habitats and get into super specific niches that most other insects can't, that's another reason why beetles are thought to be one of the most diverse, or beetles are thought to be one of the most diverse groups on the planet. Now, as a not so secret, very dedicated beetle lover, there is a bit of controversy with what is the most speciose and diverse group. Beetles currently have it. There's about 350 to 400,000 described species of beetle. And there's about 250 to 300,000 described species of wasp. But with how specialized beetles are on plants, you have wasps that are even more specialized, and we've talked about parasitism, we've talked about hyperparasitism before. So, as a coleopterist, I do personally think that Hymenoptera, the ants, bees, and wasps, are probably more diverse than beetles, but they are about 100,000 described species behind. So, my stake in this argument is Hymenoptera people get good, beetles on top for now, and unless you really start speeding stuff up, beetles are going to be on top until I die, so that's all I care about. Ben, any tips for finding buprestids? Yeah, beet sheets. Beet sheets are good, and so are sweep nets. If you go on flowering plants, anything right now, even during animal care chats the other day, we were looking at some plants, there were some buprestids on the plants. So beet sheets and sweep netting flowering plants are definitely good places to go. Or if there's a forest fire nearby, wait till it calms down a little bit and see if you can find any of the pyrophilic ones. Such a struggle to be a beetle. So true. Talk about Kafka. Oh, the classic Ringo, John, Paul, and George joke. Classic, classic, classic. Damn, so you're a fire ant stan. That's... Everybody has a favorite. I was going to say that's crazy, but everyone has a favorite. Everyone's allowed to like what they like, even if it's a bad opinion. Oh, Nicole, we were talking about, I think Tortilla asked it, actually, was asking about beetles and fire. So we talked about the jewel beetles that show up after a fire to lay their eggs in the burnt wood. And we also talked about the ground beetles. There's this one genus specifically that I'm thinking about that is also reported to show up with fire in really, really high numbers. And I don't really know why, because they're not laying their eggs in plants, they're predatory. So it's hard to make a justification as to why they would show up after a burn when they can't feed on, like, the downed trees and stuff afterwards. Perfect ones would be adults only trunk looking to lay eggs then. Yes. Yes. Catching that. Silvera, it's not beef. It's not beef. But we do have our own separate society meetings. There's the big national entomology meeting, and then within that you will have the Coleopterist Society, of which I am a lifetime member. And then there's also like the Hymenopterist Society, the Orthopterist Society. So it's not that we have beef, it's that we've all specialized so much because there's so much in the world of entomology that you can't be good at everything and you can't know everything. And so you specialize. I became a beetle guy. That's who I am. But it could have gone another way. I could have gotten into flies in a different life. Not this one, but a different one. Yeah, so Limno, we'll wrap it up here with your question. Does entomology include aquatic bugs, like fully aquatic, not just on the surface? Yes. Most aquatic insects do become terrestrial at some point, but a lot of the aquatic entomology is used for like water quality indicators. So things like dragonfly nymphs and caddisflies and mayflies, that is a huge part of entomology. There are like forest stream health entomologists that their whole thing is being able to recognize and identify insects that are collected in water. I will fully admit that aquatic collecting is a totally different realm I do not have a lot of experience with. But it is very cool. It does definitely get included within entomology. It's just not the branch of entomology that I particularly work with. Nikki, I thought I answered that when I popped into chat for that. I thought it was just another paper wasp, unless there was a different clip. Ben, I know enough to get by. I've taken some classes on other groups, but beetles are definitely where it's at. All right, y'all. It's time. We have hit our limit. I have to go out and creep around looking for scorpions with a blacklight, so I'm going to run home, grab some dinner before I have to go out and do that in about an hour. But pleasure being here with you all. Appreciate it as always. Thank you for being here. Thank you for having so many good questions. A big shout out as always to Logan driving our cams. We found some real good stuff this week, so guess we'll keep him on for next time too. Join the bug cord, ! Bug cord. We hang out in there throughout the week. I also will post recaps. So tonight I will go home and find links to talk about ancient dragonfly nymphs, gynandromorph moths, and pyrophilic insects. Oh, and that'll be it for me. I will see you same time, same place next week. And I will see you all later.